Hello guys, welcome once more to another video in our YouTube channel. So in this video we continue looking at the Polytechnic Yaoundé solutions to 2022 maths paper 2. So we are going to be solving exercise 2 and we are going to be solving just the first part of exercise 2. So without wasting much of your time, let's get started. So in the previous video, like we saw that paper 2 was divided into 2 exercises and a problem, and we solved the first exercise. So in this video we are going to be solving the second exercise, but just the first part of the second exercise. In the next video I'm going to do a combination of the second part of the second exercise together with the problem, so that the videos are shorter than the previous ones. Alright, so exercise 2 in general was allocated for 5.5 points, and it was talking about basically study of functions. So the exercise reads, the main objective of the exercise is to get the interval of lim 3. So it reads, given that C is a representative curve of the function f of x equals 1 on x, which is restricted on the interval 1 to 3 by the points A and B on the curve with respective abscissa 1 and 3. Sketch C. Question A. Determine the equation of the tangents to C at a point with abscissa 2. Prove that for all x greater than 0, 1 over x is greater or equal to 4 minus x on x, and interpret graphically this result. Question B. Give the equation of AB. This means that when you see this representation, it means you should give the equation of the line AB. So this means line. Alright. Next, prove that for all x in the interval 1 to 3, 1 over x is less than or equal to 4 minus x over x, and interpret your result graphically. Question 2. That's where we are ending in this video. Hence, deduce that lim 3 lies between 1 and 4 and 3. So in the next video, like I said, I'm going to do the second part of the exercise, which is question 3, that's on generalization, and I'm going to combine it with the problem itself, so the video is shorter. So let's get started with the solutions to the first part. Alright, so we are going to begin with sketching the curve C. I read the equation already, so we have to sketch the curve C, and the curve C is the representative curve of the function f of x equals 1 over x restricted on the interval 1 to 3 by 2 points A and B whose respective abscissae are 1 and 3. So the graph of 1 over x is actually f of x equals 1 over x is a decreasing function. Okay, so it means that I'm just going to give you the sketch. You can study the curve by yourself. Alright, so this is a sketch of the function f of x equals 1 over x restricted on the interval 1 to 3 by these 2 points A and B. So the x coordinate, abscissa means x. Okay, so x coordinate of A is 1, so the y coordinate will be f of 1, which is 1. So the point A is at the point 1 1, so the x coordinate is 1 and the y coordinate is 1. The graph is decreasing in that interval. Alright, and then the point B, the x coordinate is 3 and the y coordinate is f of 3, which is 1 on 3. So you clearly see that as x is increasing, the function is decreasing rather, so it decreases from 1 to 1 on 3. So that's a sketch of the graph in the interval 1 to 3 restricted by the points A and B on the graph. Alright, question A is now saying we should determine the equation of the tangents to the graph at a point with abscissa 2, and then we prove that for all x greater than 0, 1 over x is greater or equal to 4 minus x over 4, and we interpret the results graphically. So let's begin with the first part, meaning determine the equation of the tangents to the graph at a point with abscissa 2. So the equation of every tangent, let's just generalize this, say the tangent at a point P with x and y coordinates A and B. The tangent line is given by y minus b equal to m into x minus a. B is the y coordinate of the point and a is the x coordinate. m is simply the gradient at that point. Now in this case, our point P has x coordinate 2, so the y coordinate is f of 2, which is 1 divided by 2, and like I said, m is simply the gradient at a point, which is f prime of 2. So the tangent line at the point with abscissa 2 is given by y minus half, because half is a y coordinate equal to m into x minus 2. 2 is the x coordinate, and m being equal to f prime of 2, we need to find f prime of x. So f of x equal to 1 on x, it means f prime of x is negative 1 on x squared. So from there we can get our m, which is f prime of 2, which gives us negative 1 on 2 squared, which is negative 1 on 4. So we can impute that into our original tangent line, and we get y minus half to be negative 1 quarter into x minus 2. We can simplify and we get that the tangent line is 4 minus x divided by 4. Now the second question is asking us to show that for all x greater than 0, 1 over x is greater or equal to 4 minus x on 4. So it is always difficult to compare two functions, but it is easier to compare a function to 0. So if I subtract both sides of this equation by 4 minus x on 4, it means proving that 1 over x is greater than 4 minus x on 4 is equivalent to proving that 1 over x minus 4 minus x on 4 is greater or equal to 0. So let's first of all find the difference between 1 over x and 4 minus x on 4. Then we now verify if it is greater than 0. Then we conclude. So 1 over x minus 4 minus x on 4, we can look for the LCM and then we simplify. You get that it is equal to x squared minus 4x plus 4 over 4x. You can try to simplify and identify that the numerator is a perfect square, x minus 2 all squared. This 4 in the denominator is the same as 2 squared. You can combine x minus 2 all squared over 2 squared with indices and you get x minus 2 over 2 other squared, but there is still an x in the denominator. Now we need to verify the sign of this function. Now you see that this x here is greater than 0 initially, so 1 over x will also be greater than 0. Now this x minus 2 over 2 all squared is a quantity which is always positive because it is the function squared. So no matter what is inside here, whether it is negative or positive, whenever I square it, it will always be positive. But then it can be 0 provided x minus 2 is 0, meaning if x is equal to 2, then it can be 0. And clearly x can be 2 because it's the x coordinate of our abscissa. So it means that x minus 2 over 2 all squared is greater or equal to 0. You're multiplying something which is greater or equal to 0 with something which is strictly greater than 0. You're going to get something which is greater or equal to 0. So from here we can already draw the conclusion that 1 over x minus 4 minus x over x is greater or equal to 0. So 1 over x is greater or equal to 4 minus x over x for all x greater than 0. Now what is our graphical interpretation of the result? Now we clearly see that this is a function 1 over x, meaning the representative graph of the function f, and 4 minus x over x as seen is our tangent line. So if 1 over x is greater or equal to 4 minus x over x, it therefore means that the tangent line is always below the curve at that point, or the curve is always above the tangent line. So that's the graphical interpretation of our results. Okay, so clearly that is the tangent line. Okay, here is a point with abscissa 2, and then that's the tangent line. So you see that the tangent line is always below the graph for all x greater than 0, or the graph C is always above the tangent line. Both of them are equal when x is equal to 2. So the next question, we have to give the equation of the line AB. Like I said, whenever I see this representation, it means a line. Okay, AB means a line. Now if you see this other representation, let me just try to use a pen to indicate the next representation I want to give. So if you see this other representation, meaning you see something like this, AB with square brackets, it means a segment. But if you see AB with parentheses, it means a line. So AB with square bracket means a segment, and AB with parentheses means a line. Remember, a segment begins from somewhere and ends somewhere, but the line has no beginning and it has no end. Alright, so what is the equation of a line? General equation of a line is simply a line passing through 2 points A and B is given by y minus ya equal to m into x minus xa. You can also use y minus yb equal to m into x minus xb. I just use a because it's simpler to use the coordinates 1 and 1. It's going to be a little bit tedious to use 3 and 1 on 3 to simplify. So that's why I'm using the x and y coordinate of the point A. Now what is m? M is the gradient of the line AB, okay, and the gradient of the line AB is change in y over change in x. So if you do change in y over change in x, it means you have yb minus ya over xb minus xa. You have all the points already. This is xa, this is ya, this is xb, this is yb. If you do the difference correctly and the ratio, you're going to get that the gradient is -1 divided by 3. So from there we can get that our equation of the line AB will be y minus 1, ya is 1, m is -1 on 3, and xa is 1. If you simplify, you're going to get that the gradient, the equation of the line AB is y equals to 4 minus x divided by 3. Now we have to prove that for all x restricted in the interval 1 to 3, 1 over x is less than or equal to 4 minus x on 3. Alright, so we are still going to do same thing we did previously. We are going to subtract the two functions and then we verify the sign. So 1 over x minus 4 minus x on 3 can be written and simplified as x squared minus 4x plus 3 divided by 3x. Now you can factorize the numerator and you get x minus 1 times x minus 3 over 3x. But now x is in the interval 1 to 3. It means if you consider the upper part of the inequality, you have that x minus 3 is less than 0. If you consider the lower part of the inequality, it means that 0 will be less than x minus 1, meaning that x minus 1 is greater than 0. So the numerator of my difference is x minus 1 times x minus 3. So I'm multiplying x minus 1 and x minus 3. I'm seeing that x minus 3 is negative and x minus 1 is positive. So when I multiply something negative and something positive, I get something negative. So it therefore means that this difference is negative. Therefore, if I send this man to the right hand side, I'm going to arrive at the proof. So in conclusion, we can conclude that for all x in the interval 1 to 3, our 1 over x is less than or equal to 4 minus x over 3. So this is the equation of the line AB, and we can graphically interpret this result as that the line AB is always above the graph of the function f. Okay, you can clearly see it from the graph. The line AB is always above the curve, as you can see in the interval 1 to 3. But if you surpass this interval, you're going to see a different result. But since you are restricted in this interval, then the equation of the line AB is always above the curve, the representative curve of the function f of x equal to 1 over x. So that's our graphical representation, interpretation of the result. Finally, we have to deduce that 1 is less than or equal to ln 3 less than or equal to 4 divided by 3. So in the previous question, we have proven that 1 over x is greater or equal to 4 minus x on 4, and we have also proven that 1 over x is less than or equal to 4 minus x on 3. It therefore means that 1 over x lies between 4 minus x on 4 and 4 minus x on 3, because it is less than 4 minus x on 3 and it is greater than 4 minus x on 4. Now you see that for us to have a ln 3 here, we just need to integrate 1 over x, okay, from the interval 1 to 3. So integrating it, you're going to have integral from 1 to 3 of the left hand side of the lower bound less than or equal to integral from 1 to 3 of this less than or equal to integral from 1 to 3 of this. Now if you integrate from 1 to 3 of 4 minus x on 4, you're going to have x minus x squared on 8 from 1 to 3. If you integrate 1 over x with respect to x, you're going to get ln x now from 1 to 3. If you integrate the upper bound, you're going to get 4 on 3x minus x squared on 6 from 1 to 3. Just feed the upper and the lower bound and subtract. The middle is going to be ln 3 minus ln 1, which is ln 3, which is what we have. Now if you subtract this carefully, you're going to get 1, and if you subtract this carefully, you're going to get 4 on 3. So you have proven that ln 3 lies between 1 and 4 divided by 3. Alright, thank you guys for watching. See you in the next video. Stay tuned for part 2 like I said in the beginning. If you have not watched the solution to paper 1 complete solutions, make sure you go to the channel, you check on the playlist of this channel, you check on the name of the playlist where all these videos are. The name is ENSPY math tutorials. So you check on it, you're going to see the paper 1 of 2022, the paper 1 of 2021, and the paper 2 of 2021. Paper 1 and paper 2 of 2020 sub videos. Okay, so stay tuned for the next video solving part 2 of this exercise together with a problem. Thank you for watching and see you in the next video.